Alright, depleted uranium. It's 99.8% U-238 and 0.2% U-235. Today we'll be examining the military use of depleted uranium and the controversy surrounding it. So first of all, how do you get depleted uranium? Well, you start off with raw natural uranium, and typically you want to enrich that to either make nuclear weapons or for nuclear energy purposes. So you want the U-235 for that. So after you refine the uranium, you end up with two materials, one with a higher concentration of U-235 and one with a higher concentration of U-238. And depleted uranium is the material with a higher concentration of U-238. So depleted uranium is used for military applications, mainly ammunition. And let me explain why it's used for ammunition. So the goal here behind an armor-piercing projectile is to, as the name implies, penetrate armor with as much kinetic energy as possible so you kill whoever's on the other side of that armor. To do this, you jack up the kinetic energy and limit contact area. Jacking up kinetic energy is self-explanatory. More kinetic energy means you hit harder. The most efficient way of doing this is by increasing the projectile velocity, because look at the equation for kinetic energy, 1/2 mv squared. However, as you increase the velocity of your projectile, eventually you'll hit a point where your armor penetration starts to drop off. And that's called the shatter gap. Basically, if you shoot a material at something fast enough and it makes impact, depending on how strong that material is, it will just shatter. And that's not good for armor penetration. So the shatter gap is somewhat dependent on density. So using denser materials will both add to your kinetic energy because, more density, and assuming it's a shell of the same size, you have more mass, and it also raises the shatter gap, and both of these allow you to put more energy into the shell. And limiting contact area, if you were to stab through something, you want something pointy, and that's basically just limiting contact area. It's the identical concept here. The modern armor-piercing fin-stabilized discarding sabot shell, or APF-SDS, does this very well. There should be an image of it here. You can see it basically looks like an arrow with a very small forward area. However, the problem is when this projectile hits armor, the head tends to mushroom out. So this creates a larger surface area that's trying to push through the armor. And, think about it, open palm pushing through water, that's harder than pointing your hand forward nice and sleek. Throw it forward, there's less resistance. So depleted uranium, it is good in both of these regards because, like we mentioned, high density, 19 grams per cubic centimeter, which is 70% denser than lead. So higher shatter gap, you can put more energy into it, money. And an interesting property of the material is something called adiabatic shear. Basically, when the projectile hits and mushrooms, the edge of that mushroom slices 5 to 500 micrometers thick, will begin coming off. So that will decrease mushrooming, in other words, creating a self-sharpening projectile. In addition, these shear bands are going to be pyrophoric, meaning that they ignite on contact with air. So adding this together, whoever on the other side of that armor will have a bad time if the projectile makes it through. The controversy here is that this is still uranium. The United States used depleted uranium munitions extensively in Iraq, and the numbers speak for themselves. After the Battle of Fallujah in 2004, childhood cancer rates went up 12 times, birth defects went up. It was not good. This problem still plagues Iraq today and other countries, like in the Balkans, where depleted uranium was used. However, we can't blame all of this on depleted uranium because artillery shells and bullets and that sort of stuff have heavy metals like lead and cadmium, which could have gotten into the water, and samples from children with birth defects or cerebral palsy do show high amounts of those heavy metals in their bloodstreams. However, a point against that is that depleted uranium decays into toxic substances that dissolve in water and air, uranol fluoride and hydrogen fluoride. So really, let's not try to throw away the blame here. Depleted uranium definitely has a very major impact. Multiple international organizations have called for nations to cease using depleted uranium. However, nobody has listened because these requests have a relatively negligible impact. First of all, they're international organizations, so they don't have that much power. Furthermore, the United States and Russia both have large stockpiles of depleted uranium. They both use depleted uranium in their armor-piercing projectiles. They both have UN Defense Council seats, so don't expect a strongly worded letter to them. And if push comes to shove, NATO and the East can take on the world. So as such, we can expect depleted uranium munitions to stay around, at least for the foreseeable future, until something major happens. If you're opposed to the use of depleted uranium and, children having birth defects, then go and organize. Vote for people that will promise to stop the usage of depleted uranium, or just vote for people that will make sure we don't have to go to war. I think that's the best option. I've linked the International Coalition to Ban Uranium Weapons below. If you're interested, you can go and check them out. If depleted uranium is banned, a possible substitute is heavy tungsten alloys, which is mostly tungsten, but there's also some nickel and copper or nickel and iron in there. So this retains the same high density and surface area limiting properties for armor penetration, and it's also less toxic. It's a heavy metal, bro. What do you expect? It's still gonna be a little toxic. However, it's not pyrophoric, so effects on target may be worse than depleted uranium. However, the overpressure and the projectile and the spalling itself will probably kill everyone on the other side of that armor. I don't think we have to set them on fire as well. So thank you for watching. Please like and subscribe. Please. I'm begging you.